Up, down, right rudder, left rudder, released. Okay, brakes are on. That's max brakes right now.
My name is David Stewart, and I am the external pilot for the Area Eyes PTERA aircraft. Testing this kind of an airplane and doing research with it is primarily what I've always done. The unique thing about being a pilot of an airplane like PTERA is that it's multi-engine. It has the capability, although we're not flying it with retractable gear, of being a retractable gear airplane. It is a heavy, complex, high-speed airplane, and it flies like that.
Once they get above that 70,000, 80,000 RPM, they're about 50% and they'll go together pretty closely. But down here, they're probably, yeah. Watch the heads, watch the engines.
We're here to train NASA on the PTERA airplane and get them up to speed on it. We've been flying it now for 3 or 4 years.
Can you tell me where the connector is?
Yeah, so we've been here for the past week and a half training NASA personnel to use the PTERA system. We delivered a set of checklists that they can reference to make sure that everything's operational.
Safety wire, these things could possibly come off.
We reviewed the system, and the best way to do it is hands-on. So I've had people looking over my shoulder and explained what the system is doing at all times and what I'm looking at and what I expect and don't expect to see at any given time. My role here at the flight test, I'm the ground station operator. That means I operate, I control the aircraft from the ground. I give it waypoints, airspeed, and altitude commands. It also means that I'm checking the health of the system at all times, making sure that systems are operational, that we have good link, that the computer is doing what it's expected, and that all the sensors are working properly. Come around the far corner, just do your normal figure-8 pattern, and we'll intercept our course here, because since we're going to be doing a right-hand racetrack. And then I communicate as well with the pilot throughout the course of the flight, making sure that everybody has situational awareness. And if anything is out of spec, I'll have the external pilot or safety pilot take it back and bring it back safely.
For those of you who don't know me, I'm Nick Alley. I'll be the flight test director for this first flight. So the maneuvers that we're going to be carrying out today, we're going to take off. We're going to be manually performing a figure-8 procedure out over the lake bed.
Brakes off, Dave.
All right, so the primary project that PTERA is slated for right now is a partnership between NASA, Boeing, and Area Eye, and that's in working on a shape-adaptive wing. We're designing a wing that will go on the aircraft that's sitting behind us right now that can significantly change its shape in flight using NASA and Boeing technology.
Oh, hold, we're going to do piccolo directions.
Hopefully that program will transition through a successful test flight on PTERA where initially they'll be looking at controlling that shape adaptation and how well the controller does it, how it affects the aerodynamics of the airframe, and how well the onboard flight controller is able to maintain flight control throughout the transition between the different wing states.
Antennas are in place. Go for takeoff? Go. Affirmative. All right, 15, 17, 20, 24, 28, 30, 35, 37, 40, 43, 45, 50, 55, 60, 65, 68, 70.
The way PTERA was designed, the way the airframe was designed, was to, with relative ease, allow it to be reconfigured. To be able to put on a new tail, to be able to put on new wings, to be able to extend the fuselage or even shrink the fuselage if necessary.
Piccolo has it. Piccolo.
The airframe that you're seeing fly right now is the PTERA baseline. And we call it the baseline because it is the configuration to which all future PTERA configurations could be compared. So you can find, performance deltas and compare them back to the PTERA airframe. In addition to that, the avionics, the software that's been written is highly flexible. It's a lot like the airplane. It's kind of the erector set of avionics. It could be used to add additional flight computers. With all of the redundancies and the safeties of a flight-proven system, you can add the new system on board and the PTERA avionics can turn control over to that new system on a temporary basis until the new system proves to be flight worthy.
All right, prepping for a high-speed pass. Full throttle. 115, 120, 125, 130, 134, 134. Ground speed's 145, 146. I'm really excited about the ways I think that NASA could use PTERA. Just being around this week, I've already seen people's eyes light up when they understand what we're going for here with the system design, and seeing experiments that evaluate new wing treatments or new wing mechanical designs, and allow people to actually fly experiments that otherwise might not have made it off the ground, literally. 60, 58, 55, 54, 53.
We've dreamed up of a lot of configuration, but whether or not it's appropriate or not to do those experiments on PTERA, it's really up to the engineer. It's up to the researcher to decide. And the system, as it exists, is there to support that.